How are you?
Well, good.
All right. Okay, good. So I guess Victory will be joining, right? Right
Yep.
there.
Just
Okay.
sent him a message.
Okay, good.
He is online, so.
All right, good. All right, great. Okay. Hi, Victory. How?
Good morning, everyone.
Good, good. Good morning. Good morning. All right. So you'd like to get started on the update?
Yes, yes.
Okay.
You
All
look
right.
like you're
Go ahead. Go
exercising.
ahead. All right.
Let me just share screen. Hello, Professor Harmon. All right. All right. Can you see my screen?
Yes.
Okay. I'm going to. I think there's something I need to show you that's on here on this other computer, but. All right. So I tried to apply the. Sorry. Hold on. There. So, okay. Just show
Okay.
you that. Um, applied the formula, and it's actually um, the document that Professor Harmon sent yesterday to execute the matching process. And I guess maybe I should just start from here because I think this sort of gives a picture of what I'm trying to do. Which is okay. This is the big picture in terms of first I want to basically similar to the channel base pops up. I want to generate the nodes, but instead of the nodes probably it has its ID and everything, including the ID. Now it has the position, the XY
Okay.
coordinates, as well as the radius, right? Then it adds the node. So this is the matcher doing this. It then adds the subscriber nodes to a dictionary, like a request list or subscription request list. That's at least that's for the subscriber nodes. And for every subscription request, just execute the matching sequence. And in this matching sequence, the idea is to scan through the list, execute overlap. So this is a function in the library that I will show now. And if the node overlaps, basically publish and go to the next node. And if the node does not overlap, just go to the next node anyways.
Okay. All
And
right.
yeah,
A quick question. What
yeah.
is the list that you're checking?
So there is a subscriber list at the matcher layer
I
or
see.
at the matcher
Okay.
now. Yeah.
So maybe this is for every publication request instead of subscription request.
Did I say subscription? Sorry, that was a mistake.
That should be like every publication, right?
Publish. Yeah, yeah.
Right,
For
right,
the
right, right, right. Yeah,
publication.
then that makes sense. Yeah.
Yeah,
And
yeah,
the
it's
list is the
published now.
subscriber list. Yeah.
Yes.
Okay.
So
Right.
this
Yeah.
is
So.
subscriber list. Yeah, sub list. Sorry.
Okay.
Yeah.
Okay.
So in theory, this is supposed to be, the matching sequence, and I think at the moment, um, I don't know, it's the same screen, but it's fine. Um, so what I did is I just created. This is like test values now. At the moment, the list has been created, but it has not been integrated with the big picture now. But what I did, I created three nodes. Node one and node two overlaps. If you notice in this diagram, maybe
Okay.
I should just this because it's bigger here. It has node one and node two at the same radius, and then you have node three. Node three does not overlap with node one, but node three is sort of touching the side of node two. So in the sequence, there's a sequence of events for the overlap check, which technically should be the matching check. And to test that the sequence is working, the idea is to execute that formula, and if R1 or if D is less than R1 plus R2, it means it overlaps. If it's equal, then it's touching, and if it's less, it's D is greater than R1 plus R2, then it means they don't overlap. And the checking basically is to the system is checking for if okay, so now the check here is one, if node one overlaps with node two, and these are the values, and I'm still playing. This is just for testing. In theory, or should I say, in the practical approach, these numbers will be generated by variables now. We were now saying, okay, n1 x1 n1 n2 x2, and all of this, it will be in a dictionary. But the idea is, if this overlaps, then if this overlaps, well, if node 1 overlaps with this is to check if node 1 overlaps with node 2 from this function, with the radius for node 1 and radius for node 2. The same thing with to check if n1 overlaps with n3, which is node 1 overlaps with this, which we should get a no. And checking if node 2 overlaps with node 3. Well, and in this case, we should get the nodes are, well, touching one another.
So
And
yes, we did get
if
that.
you run this, yeah, it works fine.
Okay, nice.
You can see, which is
Okay.
again like quite. I don't know why I didn't think of using mathematics.
Okay. Yeah.
But so at the moment now, if you notice, there's like a dictionary here. I'm trying to collate these. I'm trying to find a better way around this, maybe to generate random values,
Okay.
such that such that the nodes are generated, like 10 nodes are generated, for example, and for every generated node, and I guess one of the questions I had was, does it have to be visual? Do we have to have a visual element to it? Because I don't think it necessarily needs to, especially if the sequence works.
Well, it's not necessary, but it might help you in terms of visualizing and debugging. Okay, so just to help, if you find that helpful. But obviously, you can check the numbers as well. And the overlap test, if it works, then you could just also use that as print out the results.
Okay, that's fine. Then I think maybe in the actual execution of the code, I'll probably just exclude it then. I'll only use it maybe at the testing phase.
Okay, all right.
But if you notice, so yeah, the idea is to now first place all of this. So I mean, in all of this, especially the the matching part, or should I say this overlap function, all of this goes into the matcher, and the node generator basically goes into the simulator.
Right.
So in the matcher phase, the matcher is simply saving to a list or dictionary, and basically based on for every published request, it scans through the list, it checks for overlap, checks for this overlap, and then it does the necessary matching. So if there's an overlap found, basically, which is that, right, if this overlap is found, then publish the message to that node, or that node should receive the message.
Yes, that's right.
Yeah, and in the future, we'll now sort of do more in terms of if it overlaps two different nodes, and then you want to go with the one with the strongest signal, maybe the one with the longer radius or the longer distance between servers, like that. Yeah. But yeah, I think that's more or less it for now. I plan to continue this morning to just keep pushing while the momentum is there.
Okay, nice. Okay. All right, so that's the update on the implementation part, right? The simulation.
Yes.
Okay, good. So any updates on the, I guess, the paper part?
Oh no, not really.
Okay. All right, that's good. Okay. All right. So I think it's pretty close towards doing a spatial PubSub, actually, because all you have to change, in fact, with your original channel-based PubSub is maybe just to replace the overlap check from name string comparison to overlap test. So you can actually dig up your previous code and just add that, and you should, somehow be able to support a spatial base pops up now.
Yeah. Yeah.
Okay. So I think that should be the next step. Okay. And the main thing. All right. So I guess Herman, any feedbacks on your side?
So the one thing I wanted to ask is about. So I think the system should, the question is, what do you do when the two areas touch but not overlap? And my suggestion is actually that we handle that as not overlapping. I think that's just simpler to handle it like that. Because otherwise, I mean, technically the only point where they overlap is that point where they're touching. So I would, that I would handle that as an.
I agree.
Basically, yeah.
So no match.
Okay, so yeah, if you've got this test, then I think should be. If you've got the channel-based one working, so you basically now have the test. You could literally just write a small function which says input the two areas of the nodes, or the circle position and the radius, and then there's an answer which says, overlap or not, and then based on that you add it to your so that should be actually fairly simple to implement to have a spatial-based routing.
Okay. So any other feedback from Herman? Okay.
I think not at the moment. No, I'm trying to think of what next, but
okay, all right. So the I think a couple of things we can discuss. Okay, and one thing I'd like to feedback first. Also, I think suitable for the time being is that I would encourage Victory to sort of have a feel about the similarity and difference between the channel-based and spatial PubSub. Okay, just be mindful, I guess, of what you are changing and modifying. Okay, and if this is done right and done well, I think you should have like a minimum change.
Yeah.
Okay, and I think by that I mean that, for example, like when you are doing a subscription request or publication request, you are just sending that to the matcher, right? And in fact, if the request can, either be a channel-based or an area-based, spatial-based, actually the requests can all be the same. I mean, what I mean by that is that the function you call are exactly the same for channel and also spatial, okay? And the only difference is in the matching, right?
Okay. Yeah.
Right now we are separating them, I think. Sorry. I mean at least the message type is being separated, right? So we do have like a separate maybe handling, but try to see if they can be made as similar as possible. Okay, the channel-based versus spatial, and I think this is useful when you are presenting and explaining to people that spatial PubSub is really just a simple extension from channel-based PubSub. You see?
Yeah.
Okay.
So I mean, like the moment you said it actually clicked that it could just be, well, you just said it, an extension, like it's something you are adding onto the channel. So a node can have both the channel as well as the location data. Like I think that would be the major difference between the
right. Exactly. The only difference is actually in the request itself, right? How do you define what is called the another term will be the subscription interest and the publication interest. Okay. If using the terminology of from virtual world, it's called interest management. In the good old simulator days, virtual simulation days. I'm sure Herman has heard of this term, interest management, right?
Yeah, I bet, yeah.
That's actually what it's called. That's what it's called.
Yeah.
Interest management. Okay. So I guess this is just to highlight, how this goes back and related to other existing disciplines. And I think in your work, it would be useful, as we discussed yesterday, to sort of educate people about what is this problem and why is it important, right? And part of that is to explain what is spatial POPSOP and how is it different from channel-based, right?
Yeah.
Okay. But the other thing I think is also how do you implement one, right? Let's say you agree spatial POPSOP is nice, then I want to get it done. Then what's the difference? I think that's another aspect you can point out. Okay. Like for here, it's really simple. You just change. Actually, just the subscription publication interest can indicate an area instead of channel, and then you change the overlap test, and that's it. Okay.
Yeah,
okay.
I see that. Yeah.
You see. I mean, try to explain people in this way. Well, help them to understand better. Okay. And then I think there is another aspect of difference, which is actually in, I think, the main body of this work, which is how do you decentralize this intra-management part or the matchers work? How do you make it from one matcher into multiple and potentially unlimited, like scalable matchers? Right? I mean, that's the next question. So in terms of the next stage work, I think it's, I mean, for today, I would still like to, I think it's still important to finish the implementation first. Okay, to make sure spatial POPSOP works. Okay, but the next step, this is something you can think about, is how do you actually start to split the workload of a single matcher into multiple ones, right? Okay, you see, and I think that's also the part where you might want to explain. There will be, I mean, how is it different? For example, like when you want to decentralize channel-based POPSOP, let's say, versus when you want to decentralize spatial-based POPSOP. What's the similarity and differences? You see? Okay. And and obviously, we can look at this problem from the perspective of how do you divide I guess what you may call the namespace. Okay. For example, in channel-based, the issue essentially is you have all sorts of channel names, which are basically strings, right? All kinds of strings of different lengths.
Yeah.
And how do you divide that onto various servers or various matchers, right? So that the workload can be distributed, and also a new request, when it comes to the system, it can be forwarded effectively, efficiently to the right matcher to be executed, right?
Oh, yeah, I see.
You see the picture? I mean, when you decentralize something, essentially, it's a question at its core. How do you do a kind of a partitioning, okay, of the namespace, right? I mean, that's what you do with channel-based, stream-based. But then with spatial-based, it's a question of how do you effectively divide the spaces, right? Again, in an effective manner, right?
Yeah.
So when request is coming to the system, again, it can be forwarded to the right matcher or the right region, right, to be handled and processed accordingly.
Okay. Just to follow up on that, So in this like spatial case scenario, are we okay? I'm guessing we are leaving room for both like static nodes and nodes that are moving.
Exactly. That's true.
Okay.
That's true as well.
Okay.
Yes.
Okay.
Because if you have a general enough system, then you should be able to handle both, right?
Yeah. Yeah.
Both stat, and in fact, you can argue the system we want to design is actually one that can handle dynamic nodes. Okay, because static nodes is just a specialization of dynamic nodes.
Okay.
Right?
Okay.
It's nodes that's not moving, right?
Okay. Yeah. Yeah.
Okay.
Yeah. Okay.
Okay, that makes sense.
Yeah. Yeah.
All right, but I think the reason why I'm mentioning or what I like to convey is as you're doing this, both the current, pub/sub matching, and also maybe when you're splitting the matchers in the near future, try to be aware of, like just how similar and different between channel-based and spatial-based pub/sub.
Okay.
Okay. Because I think paying attention to this, well, it's going to help. I mean, not just you to sort of see things more in perspective, but also I think you'll be able to tell your readers, when you're writing the paper, to sort of explain to them and let them understand quickly, like, what is this? Why is it important? And how is it different?
Okay. All right.
Okay.
Makes sense. It makes sense. Okay.
Okay. All right. Good. So I guess regarding the paper aspect, Herman, you have any, any suggestion as to what we should be seeing? Because I think after this week, it's 4 weeks in countdown towards July.
Yeah, like I was thinking about that like 2 days. I think I was with my leader, and I was like, "Geez, it's like 4 weeks left." But yeah, there is definitely some urgency on my side as well.
Right.
Especially from the implementation side. I need to finish that in what, a week max.
Okay.
So I can
I see.
focus on, yeah.
So Herman, yeah, and any thoughts on this? I mean, like, what do you think? What would you like to see, and what do you think we can do?
Well, so okay, I think for the doctoral symposium, I think preliminary results. I mean, you don't have to have the whole system up and running, but I do think you have to have some kind of system up and running, which you can say, hey, at least in simulation, this scales up to so many type of users or something like that. I like the angle of, contrasting spatial-based and channel-based pub/sub, basically saying these are where it's similar, this is where it's different, especially in terms of the scalability aspect, which Shinyun mentioned as well. This is how channel-based pub/sub does scalability. This is why it's not good. This is why it's not effective if we want to do spatial-based routing, and then saying, okay, but with spatial-based pub/sub, this is why we want to use a Voronoi, partitioning in order to do more effective routing in a spatial domain. So I think that contrasting of the channel-based and the spatial-based, I think, is going to be something which is going to be important to the paper, because it illustrates, why do we need something in addition to channel-based pub/sub? I think it would be good if you can. If you can think about what is it that the spatial pub/sub needs to demonstrate for it to be a viable solution to the problem of spatial routing, if that makes sense. So in other words, because I think, so, and I'm going to link into what Shinyun also said when he did his PhD, is what is the graph that you want to show people that will convince them we should be using spatial PubSub for this communication problem, for this message dissemination problem. And I think on yesterday we already spoke about, you should have some kind of a number of nodes and the number of messages scales that each node needs to send scales, less than linearly with the number of nodes in the system. I think you would probably need to have something similar for latency. In other words,
yes, yeah,
yeah.
agree.
Latency might get slightly more interesting because I think if there is, because spatial wise, I think you might need to do something like saying, okay, but we assume that the communication is within a certain region. Because I think if you want to do spatial communication over the whole world and you're communicating from South Africa to America, then there's a very large number of nodes that will be involved in passing the message along until it reaches its intended destination. And maybe there, for that long distance communication, you don't want to do something like, Voronoi. You want to do something where you've got like, I don't know, call them shortcuts to reach those long destinations. But I mean, that I think that's latency as a function of the distance that you want to communicate, and perhaps also as a function of the number of nodes in the system, I think is also an important graph, and you should think about
in terms of scalability, right?
Yes. Okay. And then I think the other one which is important is what's the amount of, and this might also be messages as a function of nodes, but in other words, what's the bandwidth consumption as a function of the number of nodes? And here I'm actually slightly more worried about the Voronoi layer, the vast layers, what do you call it? The administration traffic. The traffic you need in order to make certain that you are connected to the right neighbors and can send messages to them. Okay. So that should be scalable as well.
Right. All right. I think maybe just from what Herman just described, I have some thoughts and also a bold suggestion.
Oh, cool.
Okay. Well, let me explain the thoughts first. The first is I think we definitely should do this in stages. Okay. Actually, I would call Voronoi a kind of optimization because obviously we know spatial partitioning, there are different kinds, and you don't have to use Voronoi to have the same effect. Okay, it can just be like a very simple rectangular or square-based partitioning of the space. Okay, and you can achieve the same results. It's just that it may not be as optimal. Okay, as Herman was, I think interestingly enough, talking about scalability in terms of the distance travel, right? Because the good thing about Voronoi is it's actually density based. You can make it such that the region is bigger or smaller depending on the nodes it manages. So that in terms of the density of nodes, you can make it sort of low balance, more or less similar. Okay, but that actually is optimization. I see that as optimization, for the time being for this work, I think we can maybe, skip or stop, we don't have to think about Voronoi. We can mention that as future work, okay? And that we consider that it may be more effective, okay? To do like spatial forwarding, for example, partitioning, yes, more effective partitioning. And the bold suggestion is actually to seek help to do the implementation. Okay. From Alida and and our friend in Ezio. Okay. And I think Victoria can focus on the paper part and on the design part.
Okay.
That is actually a bold suggestion. And I will explain my reasoning behind is that I think I mean there's going to be work in terms of writing and polishing the paper itself, and if we only have a month left, I think just in itself that would be like a pretty major work. Okay, and if Victory can focus on that, then I would expect we would have something better in writing. Okay.
Yes,
by the
that's
end of
true.
1 month,
Yeah.
Right.
Yeah.
And it's not to say Victory will not do any coding or implementation. It's just that in terms of the 80-20 principle, perhaps Victory can focus 80% of your time and attention on the paper writing part. Okay, because that is something only you can do. Okay, if it's anybody else writing, then you know they should be the first author. Okay.
I see.
You see my point?
Yeah,
But in terms of implementation, you know, we can seek as many people for help as possible, actually.
Okay.
Okay, so that is my thought and suggestion. So what does Herman think?
Yeah, I think that's a good idea.
Okay, Victory, what do you think?
Yeah.
Okay.
It has worked in the past with great
Okay,
results.
all right. So, but that if you all think that's a good idea, we actually have to adjust the team structure a little bit. In that Victory will kind of become like the team lead and the main liaison point of coordinating the implementation progress. Okay.
Okay.
So although you might be doing less coding, but you will need to know for sure, like what is the current code, the progress in terms of the coding part, and be able to, you know, sort of update and report during the sync time, because you are the only person who can sync 4 times a week, you see?
Yeah.
And live, right? And so you might need to find other times to schedule regular sync with both Alida and, you know, Ezio. Okay, it's best if you can sync together, but if not, you know, separately, that's fine as well. But basically, you need to be able to like track and I guess assign next step work for them.
Task. Okay.
Okay, and don't worry, because in our sync with us, I think we can tell you like what's the next thing we'd like to see in the implementation, and you can convey this to the other 2 team members.
All right.
Okay,
That's
you
fine.
see, you see that.
That's fine. Yeah.
I mean, there's a logic behind, right?
Yeah.
Okay.
Yeah.
All right. So Herman, what do you think?
Yeah, I think that's a good idea.
Okay. Okay. So maybe let's try that. Okay. And you might have to decide like who will be like the main or lead developer in this. Okay. And I think the main criteria is the amount of time that he or she can spend on this. So we will have a main developer and also a supporting developer. Okay, and I think you can decide and you can determine like who should be the lead one and the supporting one. Okay, after maybe talking to both of them and understanding about their schedule and stuff, right?
Okay.
Okay.
Well, that's fine.
Okay, so that is something maybe you can update us tomorrow as well. All right.
All right.
Yeah, I can.
So,
I know Alida told me on Monday that you know she might have some, you know, be able to spend quite a significant amount of time on this.
Then
so,
that's perfect. That's perfect, right?
Yeah.
And maybe we can consider her as the lead developer, you know, in this.
Yeah.
Okay. Nice.
Okay. Yeah. All right.
Sure.
So obviously, you will have to spend some time to explain the current code structure. You know, like go over with, you know, sort of transfer the knowledge or the current state, right? But then you will, you know, become her responsibility to I guess to take over and maintain the most of the development.
All right.
Okay.
Makes sense.
Will that be okay? Okay.
Yeah.
All right. So I think that's a good turn, and I hope that will, you know, speed up things and have, you know, we all focus on our unique ability.
Yeah.
Okay.
No problem.
All right. Okay. So I'll sync tomorrow then. All right.
Yeah.
All right.
Cool.
Okay. All right. All right. Okay. So thanks.
Thanks,
all
everyone.
Right. So take care. Yeah. Take care.
Thanks.
Bye bye. Bye bye.
Cheers.
Bye bye.
Bye.